So now in this video, we're going to make another current mirror. Last video, I used a trim pot and a bunch of LEDs. We're going to keep this one more simple. In this video, we're going to use a light-dependent resistor to get our variable current. We'll come to that later. And we're going to use two PNP Bipolar Junction transistor. The arrow's pointing in. If it's not pointing in, if it's pointing out, it's an NPN. So the arrow's pointing in. That's important. The emitter, so this is the 2N3906. Emitter is the left pin right there. Base is the middle pin, and the collector is the right pin when you're looking at the flat side. So if we go like this and put the flat side to the left, now the emitter is on top. I'm going to that jumper to the positive rail. The middle pin, the base, is going to the middle pin of the other 2N3906 right there. And to the base, the middle pin, the emitter is also to the positive rail. So they're both to the positive rail. Their bases are both connected. So we set the current with we're going to use the transistor on the left. Before we do though, let's take an LED and the protective resistor here. And you can see the power's not on. So let's turn the power on. I'm going to use 5 volts for this video. There you can see we have a voltage to the rail and the LED is off right there. It's kind of got a reflection going from the light, but it is actually off. To turn it on, we need to get some current going through this other transistor, and to begin with, we need a jumper. So normally I would use a small jumper, but the one that only goes one spot away from the other spot is just a little piece of wire. You can't even hardly see it on the board. So I'm going to use this jumper, and I'm giving this a false signal. My body's kind of giving it a signal. So there you can see that it's enough to turn the LED on a little bit when we have it going to the transistor. So we have the base to collector of the transistor on the left, connected directly together. We'll take 220 ohm resistor and the light dependent resistor. So when there's no light on it at all, then you have over 200 million ohms of resistance. If you get a bright enough light on it, then it's almost no resistance at all. The LED. So the long lead, the anode goes more positive, short lead, the cathode goes more negative. So thing is, right now, you can see that the LEDs, no matter what I do light level wise, are about the same brightness as each other. So they should have the same current going through. And there we go. If I get that close enough without blocking the view, you can see they get really bright. We can look at the current with the power supply. There we go. So it's showing about 1 milliamp right now. When I get a brighter light on there, you can see we get about 8 milliamps of current. Let's do that. So about 8. Now I'll pluck the one on the right, and all of a sudden you'll see we go to 4 milliamps. So they were both passing about 4 milliamps for a total of 8 milliamps of current. And so you can see the alligator clip on here. This was the cover for it, and this works really nicely to cover the light dependent resistor even when you got bright light. So now they are off, and we can look at it with the low light. So even with low light, they're relatively bright there, but we get this over the light dependent resistor, you can see that it goes off completely. We probably got a couple 100 million ohms of resistance with the light dependent resistor when I cover it up like that. So pretty simple. Current that we set through the one transistor with the feedback there will be the current going through the other one. We have the same value resistor there, 220 ohm, and both of them have an LED right there. But it doesn't matter. They can be completely different. So we'll pluck that resistor. We'll move the LED. Remember, long lead the anode has to be more positive, short lead the cathode more negative. I have a little jumper here. We'll go directly to ground there. You can see the LEDs are still the same brightness. So it's not the load that determines it, unless the load has too much resistance or blocks too much voltage for the power supply. So again, 220 ohm resistors we were using, and the power supply was set to 5 volts. I also limited the current to 20 milliamps of current in case something went wrong. We short-circuited an LED or something, but that was never a problem. So that's it for this video. Hope you enjoyed. Check out one of the other videos I'm posting to the screen. Click subscribe and the bell. Make sure you catch my new videos. I will see you in the next video.